All right, everyone. Example 8 on slide number 6. This is still the same lesson, lesson 5.2. Here are the answers again for the previous slide. That was your homework. Now, with our knowledge of how to do these integrals using natural log, we could find the integrals of the rest of the trig functions. So if you remember back when we did all the derivatives of trig functions, right? But when we did integrals of trig functions, we only knew a couple of them. Because we didn't know how to do an integral of just tangent. We didn't know how to do an integral of just secant. We knew the integral of secant squared was equal to tan x, right? Because the derivative of tan x is secant squared. But we didn't know the integral of just secant. And in this example, we're going to calculate the integral of just tangent, which we haven't previously known how to do. So what we do is, it's pretty logical. You're going to rewrite tangent as its identity, which is sine over cosine, right? That's tangent, sine divided by cosine. So now, with our u substitution knowledge, we could set our denominator equal to u, right? So u is going to equal cosine x. Our du, our derivative of cosine, so if you think back to derivatives, the derivative of cosine is negative sine x, right? dx. Now, that's almost exactly what we need. We need the rest of this thing. We need sine x dx accounted for by our du, but we have negative sine x dx, so we're really just going to divide by negative 1 there, right? So we have negative 1 du equals sine x dx. All right, now we could sub everything in. So this integral, instead of sine x dx over cos x, it's going to be negative 1 du over u, which we know is just going to equal the integral of du over u is natural log u plus c. And we have this negative 1 essentially attached to it times on the outside of it. So it's really just negative natural log of our u expression, which is cos x, plus c. That's it. That's our integral of tangent of x. And if you want to check it, you could just do the derivative of this thing. Derivative of any natural log is the derivative of the inside. So the derivative of cosine is negative sine, divided by the inside, which is cosine. And we also have this negative sign in front, right? So it's going to be negative of negative sine, which is really just sine x over cos x, which is really just tangent x. So it checks. This is our check. And it worked. All right. And on the next slide, essentially all of the trig integrals are listed here for you. This is the one we just did on the slide above. We should have already known these two. We did these two in the beginning of our integral studies. And then the other three are all derived the same exact way as we just did the previous example. You would rewrite, integral of cotan, you would rewrite as cos over sine, and then do the same thing. Do the u sub, and same thing. Secant you would write as, that one might be a little trickier. Secant and cosecant might be a little trickier. You'd have to rewrite them. Try them if you want. All right, so your homework is going to be examples on these few slides. I will post that in Google Classroom right now.